The very end, the last two problems on the practice test. Practice test number 1, 8B. Okay, I need all our quizzes turned in. They're not turned in, they need to come in right now. Because problem number 8B is a word problem. Which formula am I going to use for this word problem? 8B. I'm going to use the one on the bottom here, on this side of the board on the bottom. So here we go. How much will be in the account at the end of 50 years if $125 is invested at 3.125% compounded monthly? All right, here we go. What's A? I don't know. That's what I'm finding. What's P? 125. What's R? 0.03125. Very good. Remember when you put a rate, a percentage into the equation, it has to go in its decimal form. What's N?
4. 12.
12. Compounded monthly. So N is 12 and T is 50. So I'm going to go ahead and multiply those so I only have one exponent, and that will be what? 600? Now take a second and think about how are you going to do this? Do you need logarithms? Do you need to do it? No. Can't we just type that in? First I type it in. You type it in exactly the way it is written, you should get the right answer. Now, you all have a calculator right now, so let's all type it in and make sure that we're getting the right answer. I got $595.13. Is that okay?
Yep.
All right, last one, C. How long will it take for a population to grow into this if their growth constant's this? Formula.
The
bottom one. Oh, top one. Well, your bottom one, I think. I need this one. I need PERT. Why do I need PERT on this problem? Because it's not money, right? If it's not money, you're using PERT. So here we go. What's A? 3,100. What's P? 1,300. E is E. What's R?
101.
101. And T is T? The unknown? All right, so now what?
LN.
No.
Divide by 1,300.
First I divide. Now, if you ln at this point, of course you can do that, but you're going to have an issue with this number here, because then your ln won't be next to your e. Do you see what I'm saying? The whole key is to have ln and e touching each other. So we got to get rid of that 1,300. So we're going to divide. Is it going to confuse you if I just write 13 or 31 over 13? Does that confuse you? What happens when I divide? Don't those zeros cancel? So if you want to leave them, that's fine. Totally fine.
Where do we round to?
Let's round it to 10,000. Actually, no, I think the test says round to 1,000. 1,000. All right, so now I ln, right? And then I have my ln and e right there touching each other. So gone. And so I'll get my answer by just taking this and dividing it by 0.101. So let's all type it in, make sure we know how. And if we round to the nearest thousand, did you get 8.604 days?
Yeah, that was a day.
Oh, I don't know, I made that up. Yeah, time units. I just made it up because I didn't put it in there. I didn't do a good job at all on that problem. But we okay?
Yep.
So we've made it through an entire test. I think we've been working on it for like 3 days. So let's see how much we can get through this next one. This is number 2. Notice it's formatted exactly like the first one, which is formatted exactly like your test. So problem number 1. Is this a growth or decay equation?
Decay.
Decay. How do we know it's decay?
It's less than 1.
The 0.61, the number with the exponent, this guy right here is less than 1. That means it's a decay problem. How much less than 1 is it? 39%. 39%. So number or letter B, what is the percent decay? 39%. Everybody got that?
Mm-hmm.
What is the initial value?
0.82.
0.82. So whatever this problem's about, we started with 0.82. Okay. Number 2.
This is y equals a times b steps.
It is. Y equals a times b to the x. That's your goal.
Your a is half.
Yes, your points are here. Please don't be frightened by the fractions. It's all going to work out. There's no calculator on this part of the test, so everything's going to be beautiful arithmetic. So, Olivia says a is 1/2. Everybody remember that? Whatever point has the 0, that's going to be your a value. Your y-intercept is your a value. So we end up with that. Start with that. Okay? Then what do?
Like an actual
This is a new x and a y, so in they go. So 81/2 equals 1/2 b to the 4th.
Then divide that by
We're going to,
multiply by 2.
yeah, you might think about, I'm going to divide by 1/2. Well, dividing by 1/2 is okay, but it might be easier to think of this as timesing by 2. Whatever, it doesn't matter. Times by 2. So b to the 4th is going to equal 81. You need to know, or you need to be able to figure out without a calculator, what times what times what 4 times gives you 81. 3. Because I'm not going to give you some big freakish number on a no calculator card. It's going to be something small that you should know. So don't forget to write the answer. Y equals 1/2 times 3 to the x. A was 1/2, B was 3.
Hey, that helps you out with the next problem.
Hey, it does. How about that? What is Olivia talking about when she looks at the next problem? 81 to the negative 3/4. Well, first of all, she's going to flip it and make it 1 over 81 to the 3/4.
You get 1/3, and then you always get
Then she's going to say that means the 4th root of 1 over 81
that's 1/3.
cubed. Well, she said, look, we just talked about this. The 4th root of 81 is
1/3.
3, so this is 1/3.
And you get 1 over 27.
Cubed would be 1 over 27. Now, some of you have got this down and you're just rolling through. Did everybody else keep up with that? All right, B. Some of these are really easy. 2 to the negative 3rd,
1/8.
1/8. Remember, 2 to the negative 3rd means 1/2 to the 3rd, which is 1/8. 16/9
81 over
to the
256.
negative 2nd.
You flip it.
First I flip it, so I get 9/16 squared.
Yep. Then you get 81 over 256.
81 over 256. Now that's kind of big without a calculator, but sorry. Sometimes life's hard. Everybody okay? Kind of rolling through it. Okay, D,
Negative 6.
-6. Ava, do you remember the LNE crosses out, so the answer would just be -6? E, little bit tricky. What is your thought on problem E?
Equals X.
So one option I heard over there was set it equal to X. Because if you set it equal to X, you can loop-de-loo it. 5 to the X is 25. So X would be 2. So the answer to the problem is 2. 5 squared is 25. Okay, I need to hand back yesterday's quiz. And we need to go over that. Because we missed, some of us missed the problem like this. We had one of these on yesterday's quiz, remember? And we're still missing these. I'm not sure what's going on. Let's look in here. Okay, so I got a 3 and a 4.
Yeah.
All right, now slow down.
X is gonna be on the
See
top.
how these are negative?
Yeah.
That means they're gonna switch places.
Yeah.
So I'm gonna have the X to the 4th on the top and the X to the 3rd on the bottom, right?
Yeah.
Then they're gonna cancel. Who has more?
At top.
How many more? So you're gonna have 1X on the top. Nothing moves. You got 2 Y's on top and 1 Y on the bottom. So when they cancel out, you're going to have 1 Y on the top. And then we're gonna square. So we have 9 and 16 and X squared and Y squared. Now, it didn't happen in this problem, but I want to just step aside for a second and remind you that if there had been an exponent on that, when you square it, you don't square the exponent. What do you do with these two? You multiply. When you have double exponents, you multiply them. Okay? You multiply them. You square the numbers, the actual numbers, but exponents get multiplied. That was a mistake that was made yesterday. Okay, all right, what about G? 12. That's another easy one because when you have a base of an exponent and a base of the logarithm and they match, the answer is going to be whatever's in there. That's the answer to the problem. How about the log of 1/10? If you said -1, you're exactly right. I don't know what you were thinking. What I was thinking was I'm going to set it equal to X. I'm going to remember the base on LOG is 10. So loop-de-looing says 10 to the X equals 1/10. 1 over means negative.
Yep.
And 10, 10, 1, so -1 is the answer. 3/4 to the -2nd. It's gonna be 4/3 squared, which is 16/9. Hopefully the test will have a bunch like that. And a bunch like J. What's the answer to J? 6. When you have an E and an LN touching each other, gone. Okay, still no calculator. This is all no calculator. What do you think when you look at this problem? Loop-de-loo, very good. If you're thinking loop-de-loo, you are thinking right. Got one logarithm, gotta get rid of it. Some of you just erase it and solve that. Wrong. We gotta loop-de-loo it, so 4 cubed equals x plus 1, 4 to the third equals x plus 1. No calculator, what's 4 to the
64.
third? 64. If you don't know it, figure it out over to the side, 4 times 4 times 4. So x equals 63?
Yep. Divide
This looks
4.
familiar. Divide both sides by 4,
Yes.
right? Extra number, get rid of it, divide both sides by 4. So 3 to the x equals 9, easy, easy, easy. X has to be
2.
2. Divide by 3, so the log of x equals 2.
Yeah.
And then the other one is the 10.
What's the base on here?
10.
10, let's loop-de-loo it, what's it say? 10 to the second equals x?
Yep. Which is
So
100.
x must be
100.
100. Take a look at that problem, don't let it confuse you. Don't let that problem confuse you, that should be easy. Divide by 3, and then loop-de-loo, remembering that LOG means base 10.
Divide by 27.
Yeah, first thing we're gonna do is divide by 27.
You get
You're
9.
saying, oh, Miss Ford, that's so mean. Well, you know, I think you can do it.
You get 9.
Is it 9? So 1/3 to the 2x equals 9. Now, wait a minute, this is a little bit tricky.
3 to the negative, or negative 2.
Is the exponent eventually gonna have to be negative,
Yes.
right? Because it's tipped over, right? Now, what Olivia said is really sharp. Hope you can follow it. She said, I would like to get a common base. So I know that 9 is 3 squared, but since that's a 1/3, I'm gonna make this 1/3 to the negative second. What would 1/3 to the negative second be? It would flip it over and make it 3,
9.
and then square it and make it 9, right? So that's true. So then she said 2x equals negative 2, and x equals negative 1. But we don't multiply by 3. Once you get the bases the same. Now, some of you aren't gonna do that exact thing, and that's fine. Some of you are gonna think about this. And if you just think about it, you know that exponent has to be negative 2, right? So that means x has to be negative 1. So you can solve that by just kind of thinking. First, you have to divide by 27. Alright, that was a little harder. Okay, how about E? Now, on the quiz
Combine them.
that we took yesterday, guys, these problems, this kind of problem, were the ones that most, if people miss things, this is where they missed them. What do we have to do first?
Combine.
We have to combine these two. Now listen, you've ignored me long enough. Listen, you can't have 2 logarithms on the same side. You can't do it. So somehow those have to become 1 logarithm. So you have to do something to the x plus 1 and the 3. Your choices are always multiply, divide. Since that's a plus,
You multiply.
we'll multiply. And in here is going to be 3x plus 3. I am multiplying these two things.
Negative 2.
That's a distribute. So I'm multiplying 3 and x plus 1. Now what? Loop-de-loo. There's no other way, guys. If there's only one logarithm now, you don't have any over here. So you're going to have to loop-de-loo. I got 1/3.
Yep.
Yes, you solve for x. That's what you do. You get x by itself. That's your job. Figure out what x is. Now, problem F is very similar. In fact, it starts exactly the same way, but it does not finish the same way. Why does this one start the same way?
Because you combine.
Because you gotta combine. You have two logarithms over here, and they have got to be combined. Now, there's only one over here, so he's fine. But these two have got to be combined. Okay? So here we go. How am I going to combine the 2x plus 1 and the 9?
Multiply.
Since that's an add, I'm going to multiply them together. So I'm going to say 18x plus 9. Now, that's what we did over here. But over here, my very next step was to loop-de-loo. And why did I loop-de-loo? Because there's no logarithm over here. This one has a logarithm over here, so I handle it differently. This is easier. We just say 18x plus 9 equals 3.
Yes.
So 18x equals negative 6, and x equals negative 6/18, or negative 1/3.
Yep.
Now, I do have that pesky rule that says whatever you put in here, or here, or here cannot be negative. Now, if I put in a negative 1/3, that's still positive, isn't it? So that's not an extraneous root. That's perfectly okay. It keeps everything positive, so it's perfectly okay. Okay, everybody see that?
Yeah.
Okay. Perfect. All right, what about G? Now, we already have a logarithm in here. Do not ever log a log, okay? We don't want to go there. So we have one logarithm. It's very much like the problem I just erased. If you have just one logarithm, the only way to get rid of it is to loop-de-loo. So remember, the base here is E. So e to the third equals 2x.
That's how you
That cancels.
And then we're going to divide by 2. So we have e cubed over 2. And that's all you can do. That's your answer. When you have one logarithm and you're trying to solve, you got to loop-de-loo. If you have one on each side, you can cancel them out. But if you only have one, you have to loop-de-loo. So we loop-de-loo by remembering the base here is e. E to the third equals 2x. Perfect. One more. 4 to the x equals 32. Now be careful. What do we need to do, Tanner?
You take the x, put it out front, and log both sides.
I could log both sides, absolutely, but this is a no calculator problem. So what am I going to do with all these logarithms and a no calculator problem. That will give me the answer, Tanner. It absolutely will, but not without a calculator. So if I can't use a calculator, then there must be something special between 4 and 32.
They got the same base.
They have what base? 2. They're both powers of 2. 4 is 2 to the second, and 32 is 2 to the fifth. So if 2 to the 2x, remember we multiply these, if 2 to the 2x equals 2 to the fifth, then 2x equals 5 and x equals 5 halves. If Tanner typed log 32 divided by log 4, it would say 5 halves. He's gonna check it to make sure, but it'll say, so his method is absolutely fine, but it requires a calculator. So this is how you need to do it on the no calculator part. All right, a couple more no calculator problems, and then we'll do the calculator part. So here we go. Write as a single logarithm. So instead of putting them, we need to put them together just like we did before.
Where's y cubed?
I'm on the wrong problem. So it's 2 log x plus 3 log y. So I'm gonna write that as one logarithm.
You get x squared y cubed.
X squared y cubed is what I've heard from the audience. What do the rest of you think? Yes, numbers out in front are exponents. Why are these times together? Because that's a plus.
Yes.
Now the next one is the opposite.
Log x log y minus log z.
On the quiz, some people didn't have enough logarithms. How many letters are there here?
3.
3. So when you expand it, you have to have a log of x, a log of y, and a log of z. You need all 3 of them. If there's 5 letters, you're gonna have 5 logarithms. Okay? Now, what do you do with those?
You add the y.
Add these and subtract that. Now, there aren't any numbers out in front, but let's say there'd been a cubed on that y right there.
Log y.
Then this would have a 3 in front of it. Right? Okay, now I think we'll stop right there because I want to hand back your quizzes and go over those.
Oh, I haven't taken the quiz yet.
Well, I got a makeup. You'll have to do a makeup, Emma.
Same amount.
Boy, I hope that tape that whole time.